All right, everyone, and welcome to exponential growth and exponential decay. The ways that we can model a lot of things in the real world with exponential growth and decay, such as populations of animals change over time. And really, I'm going to be honest, I'm just stretching it right now. We need to get into the video anyway. I just like showing the cats, but we can actually do some math today as well. But if you made it to this video, you get some bonus cat content, all right, in addition to your regularly scheduled math con. All right. We're in 6.1 right now. I'm going to talk about exponential functions. Chapter 6 in general is going to be pretty crucial. We're going to spend a lot of time here. So in this section, or in this chapter, we're going to introduce exponentials and logarithms. What are logarithms? Some properties about them, and then go into some applications and equations and stuff like that. It should be pretty cool. I like chapter 6. This is my favorite part. Maybe not today necessarily, but my favorite part of the chapter. Okay. Oh my goodness. Sorry. Excuse me. We're going to start with example 1 for this video. We're going to graph a function. Y is equal to 2 times, I already messed it up. 3 times 2 to the x. All right. So the first thing I want to stress when we're graphing a function like this, an exponential function, is that we can't combine these, right? This is not 6 to the x. That's different. You can only combine them if they both have that x. All right. These cannot be combined. We have to graph it. We're going to make a table, plug things in, and see what it looks like. Excuse me. So here we're going to have our graph over here. Let's we're going to have to count a little bit more in the y direction. We can go 5 in each side for the x direction. And we'll go like 10 in the y direction. All right, so we're going to make our table. Just see what this looks like. Well, we'll start with my favorite letter. Number 0. Okay, so when x is 0, what do we get? We have 3 times 2 to the 0th power. Any number, remember your powers, your properties of exponents. Any number to the 0th power is just 1. So it's 3 times 1, just 3. All right, so our y-intercept is 3. And we just keep on going. All right, when x is equal to 1, what do we have? We have 3 times 2 to the first power. Anything to the first power is just itself. So this is just 3 times 2, which is 6. So we have 1, 6. And if we have 2, we're going to get 3 times 2 squared. That's 3 times 4, which is 12. It doesn't really fit on the graph, but if it did, it'd be right there. Then we can plug in some negatives too. 3 times 2 to the negative first power. What do negative exponents do? If you forget, you can check your calculator. If you type this in your calculator, you're going to get it just fine. All right. Negative exponents means reciprocal. So this becomes 3 times 1/2, which is just 3 halves. All right. So about 1.5 is our y coordinate when x is -1. We could do another one. Right, when x is -2, we're going to have 3 times 2 to the negative second. And again, that negative exponent is going to mean reciprocal of the squared, so 1/4. We're going to get 3/4 right here. All right, we can do this all day. 3/4 is about right here. And the more and more points we plug in, the more we're going to have an idea of what this looks like. All right. We get this exponential shape right here. And look what's happening to all these numbers, right? At 0, we're at 3. And then we go to 6, and then we go to 12. What's happening? All these numbers are getting doubled, right? We double 3 to get 6, double 6 to get 12. Or if we go the other way, right? At 0, we're at 3. Move to the left one, we get cut in half. And then we get cut in half again. The next one would be 3/8, then 3/16. We keep on getting cut in half to the left. We keep on doubling to the right. That has to do with this 2. This 2 is what's called the growth factor. All right, and it just says we keep on doubling. And the 3, that's our starting value. Okay, so that's in general what exponential functions are going to be. So if we have an exponential function, y is equal to a times b to the x, and again, we can never combine these. We have a couple things to say about this. All right, it has the y-intercept of a. Right, so over here, a was 3. That was our y-intercept. 2 was our b value. Excuse me. Promise I'm not dying. All right. It also has a growth or decay, depending on it, factor of b. All right, so in our previous example, b was 2. We kept on doubling. We kept on halving, okay? And then depending on what b is, it could either be growth or decay. All right, so it's growth if b is bigger than 1. So doubling, tripling, quadrupling, etc. Okay? And it's decay if b is between 0 and 1. And again, if it's a negative number, we get some weird wonky things. Let's not worry about that. Okay? So we're going to utilize this in the early homework problems. We'll talk a little bit about it with the next 2 examples. All right? That's most of the video, though. Most of the video is this logic right here. Well, let's see it in action. Okay? Not that. That's the intermediate value theorem. And you guys probably don't want to do that again. Although I guess it will be on your next test. All right, so what we've got is example 2. Identify the starting value, aka the y-intercept, and the growth or decay rate for the following problems. All right, wait a minute, I'm using the wrong scene here. Which is why up there shows what Spotify was playing. This is the scene that's particularly reserved for my cats. It is labeled cat cam. This is the, not that one, this is the teaching scene, right? So here we are. It actually, I think it's basically the same scene, but boot it up a little bit. All right, so part A, what have we got right here? We have y is equal to 1/2 to the x. And again, remember the form, a times b to the x, where a is the starting value, or the y-intercept, and b is the growth or decay rate. Well, it doesn't look like there is an a here. But don't worry, right? We can write one if you wanted. 1 times 1/2 to the x. Okay? So it's in this form, which is good. So a is equal to 1. That's our y-intercept, right? Our starting value. Then b is going to be that 1/2. It's the thing that's getting raised to the 1/2 to the x power. In this case, b is 1/2, which means we keep on halving as we go forwards or doubling as we go backwards. All right, so that's our decay rate. And again, it's decay because it's smaller than 1. All right, we're getting cut in half every time. Part B, y is equal to 3 times 2 to the negative x. Now this one is not in the right form. Right? Our standard form here has a positive x, not a negative x. So what we're going to do is rewrite it. We're going to rewrite it in that form. Negative exponent, remember, means reciprocal. The reciprocal of 2 is 1/2. So this is actually 3 times 1/2 to the x. And now we can see it that it's in that right form. All right. So again, our starting value or our y-intercept is that 3. Again, it's this number smaller than 1 as our b value. So that's our decay rate. I just noticed in my previous problem, I didn't actually write the decay rate here. It's 1/2. All right, so we start at 3. Every time we increase x, we get cut in half. All right, we'll do one more and then move on. All right, part C. Y is equal to 0.5 times 1.5 to the x. This is in standard form again. This is going to be our A right here. This is going to be our B right here. So our y-intercept is 1/2 or 0.5. I don't care if you use a decimal or if you use a fraction. And then this is bigger than 1. All right, so it's going to be our growth rate of 3/2 or 1.5. Again, it doesn't matter how you express that number. All right, so that means every time we increase x, we get multiplied by 1.5, right? 1.5, 1.5, 3/2, all the same thing. So every time x increases, 1.5 times, 1.5 times, 1.5 times, and we'll grow, okay? Right, because if you multiply by a number bigger than 1, you will grow. If you multiply by a number smaller than 1, you will shrink, okay? That's another way to remember the decay and growth rate. All right, so last thing that we're going to do in this video, and then I will send you off, complete a homework assignment, or at least part of one, is evaluate. All right, so round to 4 decimal places if needed. F of x is equal to 2 times 5 to the x, and I want you to find f of -3. And again, we cannot combine these because one has an exponent and the other one does not. So you have to be very careful with your order of operations here. Plug in -3, and as you plug 5 to the -3rds, right, that's 1/5 cubed, which is 125. And now we can multiply them, right? You get 2/125. Or if you wanted, you could approximate that. All right. So it says the full question says like round to 4 decimals where appropriate or something like that. I'll accept either here. Part B, f of x is equal to e to the x. Find f of 3. We haven't talked about e yet, not in this video. All right, but felt natural to include this problem here anyway. Okay, so again, you just do the same thing. You plug in 3. Your calculator should have an e to the x button. So on a calculator, what you should do is find the e caret x button, and then you'll type in 3 after that. And it should look like e raised to the 3 like that. All right, e cubed. And this one will definitely have to approximate, all right? So e cubed is about 20.0855. All right, we'll touch more on what this e is later, but that's how you do it. All right, if you have questions on your specific calculator, feel free to come and ask me, right? Send me a message. All right, last thing is going to be f of x is equal to 2.7 times 4 to the -x plus 1 plus 1.5. And we want to find f of -2. So again, it's a little messier here. There's a lot of stuff going on, a lot of function transformations, just like 3.5 here, but it's the same idea. You just plug it in. 2.7 times 4 to the -2 is a +2. That'll become 3 up there. And you can just type this into your calculator, okay? Type that into your calculator. You're going to get 2.7 times 4 cubed plus 1.5. You'll get 174.3. All right, and that's how you do those sort of ones. And let me know if you have questions. All right.